It is a substance of contradictions, solid yet transparent, fragile yet timeless. We look through it, drink from it, and touch it countless times a day, from the unseen barriers of our windows to the gleaming faces of our devices. Yet the origin of this remarkable material is surprisingly humble, found in the unassuming grains of ordinary sand. Each year, more than 60 million tons of silica sand are unearthed from the Earth's crust. These silent grains then embark on a fiery journey, entering the heart of vast, technologically advanced facilities. Within these walls, they are subjected to immense heat, meticulously shaped, and refined through an extraordinary process of elemental change. It is here that invisible sand is reborn as the solid, sparkling material that shapes our modern world. It can endure for millennia, yet shatters in an instant. This is the paradox of glass, a material born not of intention, but of pure accident. The story begins by the flicker of an ancient fire over 2,000 years ago. Around 300 BC, Egyptian artisans heating a mixture of silica sand and sodium carbonate watched as it cooled into something never seen before, a solid, transparent substance. From that accidental discovery, glass has woven itself silently into the fabric of our lives, forming our windows, bottles, and the screens through which we see the world. Its uniqueness lies in its internal structure. Glass possesses the clarity of crystal, yet it fiercely resists heat, corrosion, and the flow of electricity. Perhaps its most remarkable quality is its potential for immortality. It can be recycled endlessly without ever losing its purity. But for all its resilience, it is profoundly fragile. Unlike metals or plastics, it cannot bend or stretch under pressure. When pushed beyond its limits, it offers no warning. It simply breaks. To understand how this strange material is made, we must witness the astonishing transformation that turns ordinary grains of sand into something extraordinary. A substance born from explosive force, destined for fragile transparency. The creation of glass demands a special kind of sand, one of exceptional purity with a silica content reaching 99%. This pristine material isn't found on sun-drenched beaches, but is blasted from deep within the earth in vast open-pit mines. Following the detonation, colossal excavators gather the fractured rock, loading it onto heavy trucks for its journey to a crushing facility. Here, industrial mills relentlessly grind the debris, pulverizing it into the uniform, fine grains that will form the very foundation of glass. But this raw powder, though finely ground, has not yet achieved the required purity. It must now enter a sophisticated washing system, a facility capable of processing 220 tons of sand every hour. The journey begins as the material cascades from trucks into a large hopper, which channels it into a regulated flow. Its first test is a primary sieve, where precision screens with 30 holes per square inch block any oversized particles from continuing. Only the grains that meet the precise size specifications are permitted to pass through to the next stage of refinement. From there, the sand enters powerful agitation chambers, where it is scoured by high-pressure, needle-like jets of water. For nearly 15 minutes, the mixture is churned relentlessly, cleansing every grain before it begins a controlled descent into a spiral separation system. Inside the spinning vortex, centrifugal force takes over, casting heavier metallic impurities outward to be filtered away. The lighter, more refined stream continues onward, passing through a final mechanical separator that captures any lingering traces of iron before being dried and sealed in 1-ton bags, ready for the factory. A mountain of raw material arrives each week, the first step in a journey from solid earth to liquid light. This is the largest glass plant in the United States, and here over 5,000 tons of silica sand meet their catalysts for transformation. Sodium and calcium carbonates join the mix, altering the very structure of the silica to lower its melting point and ease its fusion. The calcium carbonate also imparts a hidden strength, a resilience that will define the finished glass. To achieve a specific color, pigments like cobalt oxide are introduced, the secret behind the distinctive blue hue of certain bottles. Once prepared, this granular blend cascades through a filtration system, a final purification before the crucible of creation. From there, a network of conveyor belts takes over, transporting the refined materials to the mixing zone. These arteries of the factory are engineered for relentless work, capable of moving hundreds of tons of sand each hour without pause. Inside the mixing zone, the sand churns within high-speed stirrers, ensuring every particle is evenly blended. This violent agitation serves a dual purpose, acting as a deep cleaning process that scours away any lingering impurities from the silica grains. The resulting mixture is then conveyed into a colossal gas furnace, where temperatures reach an astonishing 1,650 degrees Celsius, an environment hotter than volcanic lava. Technicians, shielded from the immense heat, carefully oversee the process as the mixture is poured into special crucibles. Once the materials stabilize, each crucible's mouth is sealed, trapping the intense temperature to control the fusion. Within this inferno, workers must wear full fireproof suits and Kevlar gloves, as the ambient heat is a palpable, dangerous force. After 24 hours, the mixture is no longer sand, it flows like a river of fire. At the bottom of the furnace glows liquid glass, a dense, incandescent mass that has reached the perfect temperature and viscosity. For several more hours, the glass remains in this molten state, allowing any trapped gases to escape and ensuring the highest purity. From this liquid state, a new form must be born, beginning not with fire but with data. Engineers use specialized CAD software to design the mold with absolute precision, dictating every curve, dimension, and thickness. This digital blueprint is then forged into a heat-resistant metal mold, ready to receive the molten glass. Once finalized, the molds are installed into the double-blow production line, a method perfected for shaping hollow containers. The process ignites as glistening drops of molten glass, known as gobs, are sheared from the fiery stream. Each gob, heated to 1,100 degrees Celsius, possesses the ideal viscosity to be shaped without collapsing. Inside the preliminary mold, a jet of compressed air is injected from above, forcing the incandescent glass against the mold's walls. This first breath creates an initial hollow shape known as a parison, a bubble of glass with a narrow neck. Still glowing, this embryonic form is transferred to the final mold, where a second, more powerful blast of air expands the parison outward. It stretches the soft glass until it perfectly mirrors every detail of the metal cavity. In a matter of seconds, the bottle's final shape is realized. Behind this seemingly simple act lies a symphony of synchronized valves and sensors, timed to 1,000th of a second. This incredible precision makes it possible to produce hundreds of thousands of nearly identical bottles each day. Fresh from the mold, they glow a fierce, cherry red, their surfaces shimmering like iron rods pulled from a forge. One by one, robotic arms glide into position, their graceful program motions gently lifting each bottle onto a moving conveyor. There is no haste, only flawless coordination. The conveyor carries the freshly molded bottles, their bases still glowing, toward a long yellow tunnel. Inside, the temperature is carefully lowered in gradual stages, allowing the glass to cool and settle without the risk of stress fractures. As the journey continues, the cooled bottles enter an inspection zone, a gauntlet of light and logic. Here, a network of optical sensors and high-speed cameras scans every bottle, instantly flagging any crack, bubble, or deformation for removal. Next, an automated system performs a detailed check of the bottle's mouth, using probes and sensors to spot chipped rims or microscopic errors in size. The bottles that pass every inspection are then transported to the palletizing area, where automated robots take command. These machines arrange thousands of bottles with unwavering consistency, using a clamp system with suction cups to lift and place entire rows onto pallets. Between each layer, a protective sheet is added to prevent damage during transit. The completed pallet is then tightly wrapped in film and labeled with a production code, its journey from sand to finished product nearly complete. Every stage of this intricate dance is monitored from a central control room. Here, operators watch over the key parameters in real time, ensuring that from the furnace to the final pallet, every standard is met before the bottles are shipped to their destinations. Mountains of shattered light rise from the ground, yet nothing here is truly lost. In this flat glass factory, waste is an unknown concept, as 100% of all scrap is reclaimed. Shimmering hills of broken glass stretch across the yard, a testament to this commitment, with every fragment waiting to be reborn as a new panel. The discarded pieces are gathered and fed onto a conveyor, where they join a carefully measured blend of pure silica sand and other agents like sodium carbonate. This precise mixture is key as the recycled glass lowers the required melting point, dramatically cutting down on the energy needed for the entire operation. From there, the uniform mass travels into the fiery heart of the facility, the fusion furnace. This immense thermal chamber operates without pause, maintaining a relentless temperature near 1,600 degrees Celsius. For a full 24 hours, the material is held within this inferno, allowing every component to melt and fuse into a single, homogeneous liquid. What emerges is a continuous, uninterrupted river of molten glass, prized for its exceptional clarity, consistency, and viscosity. Unlike the blowing techniques used for bottles, this liquid glass undergoes the float method to achieve its flat form. The molten stream is gently poured onto the surface of a vast bath of molten metal, typically tin. Due to the stark difference in density, the glass floats effortlessly, spreading out across the liquid metal and naturally leveling into a sheet of perfect flatness. As this ribbon of glass glides forward, it passes through zones of meticulously controlled temperatures, allowing it to cool evenly without warping, preserving its flawless shape. Leaving the tin bath, the glass sheets continue their journey along a long conveyor, still radiating a gentle warmth. Now precision becomes paramount. Robotic arms programmed with exact specifications glide into position, wielding diamond-tipped blades or laser tools. Each slice is executed with incredible speed and accuracy, ensuring clean edges without causing cracks, chips, or surface stress. After being cut into individual panels, the edges remain rough and sharp. A state that fails to meet aesthetic standards imposes a safety risk. To resolve this, each panel is sent through a specialized edge polishing machine. There, high-speed abrasive wheels apply consistent pressure, smoothing every side, rounding the corners, and refining the shape with pinpoint precision. The result is a glass panel with exact dimensions, not only visually clean, but also safe to handle, transport, and install. To verify its integrity, samples are taken to a testing room to check their hardness and impact resistance. If the glass cracks in a spiderweb pattern instead of shattering into dangerous shards, it is deemed safe and has met established standards. Finally, the panels that pass every quality check are lifted by robotic arms and carefully stacked onto specialized racks. Protective layers are inserted between each sheet to prevent scratches. And once secured, the entire stack is moved to the loading area, ready for shipment to factories and construction sites around the world. From a torrent of liquid fire, a wall of crystal emerges. Its journey concludes as immaculate sheets are prepared for shipment, destined for architectural marvels or the storefronts of cities around the world. This entire process is a path shaped by overwhelming heat and exacting precision, a modern testament to human ingenuity. Every step reveals a story of profound transformation. From glowing, raw material to flawless, transparent panels, the ordinary is made extraordinary. It becomes a silent witness to the world seen through it, an invisible part of our lives born in the heart of a furnace.